Yesterday, we reviewed, but we had learned it twice now, slope-intercept form. Slope-intercept form looked like this. And it has a really creative name. It's slope-intercept form because it tells you the slope, and it tells you the y-intercept. Really clever name. And this one is a super clever name too. It's called slope point form, and it's going to tell you slope and a point. Right? So it's right in the name. It should be nice and easy to know which one to use. The thing that gets tricky is once you learn both of them, you're going to have to be able to choose which equation's better to use depending on the question. So remember yesterday we were creating equations because we had slope and we had y-intercept. Well, y-intercept is also a point, right, on the graph, which is why it can sometimes get confusing on which one you want to use. We'll learn about it, then we'll talk about it again at the end so you can see kind of what I mean. Before we actually do anything in slope point form, we do this little investigation. We're going to do it twice. It's the same way we learned slope-intercept form, where it kind of guides you through and you try to see if you can figure out how numbers are correlating. So the first thing is this graph right here is this beautiful line right there. So every question that they're talking about has to do with that graph. Part A says determine the slope of this beautiful line. If you have a line, the best way to find slope is to pick 2 points, work from left to right, do rise over run. So, pick point A, since they gave it to me, and I'll pick another point right there. Let's see. I always work from left to right. Okay, so from the left point to the right point, I had to go up 2 and over 1. That means my rise over run is 2 over 1, or just 2. So our slope is 2. Question B on this thing. So list the coordinates of point A on the line. So if you look at this line, they labeled point A for you. They just want to know the coordinates of that point. So the coordinates of that point would be 1, comma, negative 3. It's the x value. So 1 and the y value is negative 3 for point A. Okay. Yeah, this goes a little different. If you look at the 3 things we just wrote down, we wrote down the slope is 2, we wrote down an x-coordinate for point A, which is 1, and a y-coordinate for point A, which is negative 3. You'll notice that all those numbers are actually in the equation that we've been talking about. So if you look at your slope 2, you notice that the number 2 is right here outside the bracket. If you look at your x-coordinate of 1, you notice the number 1 is right there inside next to the other x. And if you look at your y-coordinate of negative 3, you notice that there's a value of 3 right there beside the y. Now, this x-coordinate was positive 1. In the equation, it looks like it's negative 1. And the y-coordinate is negative 3, but in the equation, it's actually positive 3. And that's a trend that we're going to catch on to when we do it again. If you do the second investigation, you're going to notice that the trend kind of continues on, and these numbers appear in the same location. So, down here, second one, they want you to calculate the slope of this graph. Calculate slope, you take a point, you find another point, and in this case we went down 2, so negative 2 over 3. That means my slope is negative 2 over 3. Again, if you look at your equation, that negative 2 over 3 is the number outside the brackets, just like the slope was the number outside the brackets on the other one. Just like the question before, they want you to list the coordinates of a point they gave you. They want to know the coordinates of point B this time. The coordinates of point B are negative 4 and positive 1. Just like the question before, that point has 2 numbers that appear in our formula. The negative 4 is right here, and again, instead of being negative 4, it's positive 4 for some reason. And if you look, the y value, positive 1, is also in our equation, but it's in the equation as negative 1. The fact that these numbers keep appearing in the same spot is not a coincidence. The slope is always the number outside the brackets. The x value from your random point is always the number inside the brackets with the x. And the y value is always the number that's beside the y on the other side of the equation. And the symbols are always opposite. And look at them. The -4 point became a +4. The +1 became a -1. This is because these formulas are following something called slope point form. It's right here. Realistically, we're going to change the slide over so you can see it nicer. Right here at the top. This is the equation for slope point. When we talk about slope point form, I usually use this term random point because it's the equation that you're going to want to use when you have a slope and a point that's not your y-intercept. So just some point on a line somewhere. In your equation, you'll notice that there's 2 y's and there's 2 x's. The y's that have numbers on them, these guys, and the x's that have numbers on them. Those come from your point. The other 2 x's and y's, this guy and this guy, they stay the same. They stay the way they are. So when you're building an equation, it's going to be important to know which y's and which x's you're going to be changing. You'll also notice that the m is there. M means slope, and the slope is always the number outside the brackets, like you have in this question. Okay, how this works. So we're going to try building some equations. We're going to build them using this new form that we just learned. So, example 1. State the equation slope point form of the line passing through the given point with the given slope. They've given you a point and a slope 3 times. We're going to do the first 2 together. I'll let you do the third one on your own. When you look at your first one, what you need to ask yourself is, do I have a y-intercept? Is this point a y-intercept? It's not, right? A y-intercept would be 0, something. If it's not a y-intercept, you use slope point form. That's the best way to tell which form you need to be creating. Don't have a y-intercept, create slope point. When I'm creating slope point form, I take my random point, I call it x1, y1. I call my slope m. And then I go into my slope point form equation, which will be given to you on a formula sheet, so it won't be random. And you replace x1, y1, and m with the numbers that you actually have. So in our case, we would have y minus y1, 6, equals m, which is 3, bracket, x minus x1, which is 5. And I have my x's and my y's. Alright, here we go. Y minus 5, x minus 6. Just have to catch up and fix the mistake that I made earlier. Notice how all these things just matched up with our formula. Right? The y's change becomes a new y1. The x1 changed becomes the new x value from that point, and the m changed. That's an equation in slope point form. That equation represents a line with a slope of 3 that goes through the point 6. If we try it again, so we look at B, we have a point and a slope. That point is a random point. It's nothing special to us. That means we create slope point form where we say the first term is x1, the second is y1, and the slope is we go back into our equation and we create it. We're going to do something a little different on this one. The blue sticks out. When we put in y1, notice that y1 is now -1. So in our formula, that means you have minus -1. Now, how would we normally write that? We wouldn't write minus negative. We'd write positive, right? We'd just write y plus 1. I'm going to leave it as y minus -1 just to show you that there's a double negative there. But that should be changed to a positive 1 in the final answer. Okay. Be careful with your negatives. That's always what throws people off. Make sure if you have two negatives, you actually show them both so that you change it to a positive, so you don't make a mistake. Equals m, which is -4, and then x minus x1, which is just positive. Again, my final answer, if I was to actually write this out, I would go y plus 1 equals -4 x. Okay, for C, I want you to try that one. So try it on your own, see if you can build that equation. Try to make sure you don't have double negatives, change them to positives if you have any. Okay. Looking at this equation, I have a slope and a random point given to me. That tells me that if I want to make an equation, I call the random point x1, y1, and I call the slope. I then looked at my formula, which is my slope point formula, and I put in everything that I know. That'd be y plus 8. It should be minus -8, so it changes to plus 8. Equals 1/2 x plus 9. It would have been x minus -9. Remember on that last slide we were looking at, we were saying that the point was always the opposite sign? That's still holding true, and the reason that's happening is because it's minus in the formula. -9 looks like a positive 9 now, -8 looks like a positive 8 now. It's always opposite.
Two positive, or two negatives and a positive.
Exactly, and if you had minus a positive, now it looks like it's a negative, right? Okay, question 2. A good question that if you just got given to you would probably be pretty confusing. So the question says, in each case, the slope of a line and the points of line segment are given. Determine the equation of the line in slope y-intercept form. So they're saying you have to build an equation in slope y-intercept form, but they didn't give you the slope and the y-intercept. They gave you slope and a point. Even though they're asking for a certain method, you're confined to creating whatever they've actually provided for you to work with. That means you create the equation and then convert it into the form they want. Right? So if you see a question that's saying, create slope y-intercept form, but you don't have slope y-intercept, you have slope at a random point, but you need to make slope point form and then try to change it into slope intercept form. And that's what I'm going to show you how you do right now. But whenever you're creating an equation, just create whatever they give you. Okay, don't try to force one way or the other. A lot of people would look at this question and they would be like, y equals mx plus b, I'll write this down. Y equals 5x plus b. Like, I don't know what b is, because it doesn't tell me. Right, that's not going to work. You can't create slope y-intercept forms, but you could convert into slope y-intercept form if you had a different equation. For this question, we have slope, we have a random point. That means I go slope equals 5, point equals -5 over 2. That means that's x1, y1. That's why I like to write my info on the side. Do I have slope and y-intercept, or do I have slope and a point? And that'll always guide me in what I need to create. In this case, I definitely need to create slope point form because that's all I have. That gives me y y minus 2 equals 5x plus 5. You put y1 in, m in, x1. Any questions about creating or anything? Now that we've created this equation, we need to convert it into the form that it asked for. They asked for slope-intercept form. Slope-intercept form does not have any brackets. It also does not have anything next to the y. Our current form definitely has brackets and has something next to the y. So the first thing we're going to do is get rid of the brackets. To get rid of the brackets, we use the brackets, meaning that we multiply that 5 in. That's how you use brackets, right? They mean multiply. That changes my equation to be y minus 2 equals 5x plus 25. The brackets are now gone, and this thing looks really close to slope y-intercept form. The only thing that's throwing it off is we have this negative 2 right here. How can you move a negative 2 from one side to another side? So that the y could be all by itself. Right, and you do the opposite, right? So to move a negative 2 to the other side, you would have to add 2. By adding 2, you get y equals 5x plus 27. And that would be your equation in slope y-intercept form. These equations are the same thing, just two different forms. Right? They would both create the exact same line on a graph. It's just a different form. Does anybody have any questions on that one? That's a lot. That's a hard question. It's definitely something that you're going to see, though. They like to ask you to create equations in slope-intercept form, but you can't actually create it in slope-intercept form. You can create it in something else and convert it. All right. I want you to try B. So see if you can write that equation in slope y-intercept form. You're going to have to start with slope point form and then convert it. If you got stuck somewhere, that's fine, but see if you can figure out what happened at that spot. So, to create an equation, I've been given a slope and a random point. That tells me I have to do slope point form. My point gives me my x1 and my y1. So if I build my equation, I should have y minus 4 equals negative 7x plus 3. Notice that it's a plus 3 because it was minus negative 3. So that should have changed it into a plus 3. The next thing now is to actually change this equation to fit the formula that they asked for, which was slope y-intercept form. Slope y-intercept form has y all by itself. It also has no brackets. So the first thing we do, if we just follow BEDMAS, is we use the brackets, and we get rid of this set of brackets by multiplying the negative 7 in. That gives me y minus 4 equals negative 7x minus 20. Right, that'd be negative 7 times x, negative 7 times 3. At this point, I'm really close to slope y-intercept form. I just have to somehow move that minus 4 to the other side. To move something in math from one side to the other, you do opposite operations. So if this is y minus 4, the opposite of subtraction is addition. So I would do plus 4 to both sides. That gives me y equals negative 7x minus 17. That equation is in slope y-intercept form and represents a line that would go through this point with this line. On that last question we just did, y equals negative 7x minus 17. What's the y-intercept on that function? It's negative 17, yeah. That's kind of the usefulness of changing something into a new form, is it's really easy to look at it and go, well, the y-intercept must be a negative 17, and that would give you a point on a graph to start the experiment. So that's why it might be useful to convert things. Another reason it might be able to convert, might be nice to convert forms, is if you wanted to check in your calculator what your form actually looked like and graph it, remember your calculator only knows how to graph y equals x. So it needs to be in this form to be able to graph it. Alright, we're going to try two more types of questions. The first one, they give you a line and they want you to create an equation. The next one, they want you to tell them information about the equation. So the first one together, it says, the line on the grid passes through at least 2 points with integer coordinates. Okay, that sometimes freaks people out. It passes through 2 points with integer coordinates. Really doesn't matter to us. It's good to know that that graph does cross through 2 points. That's all it's really saying. Determine the equation of the line. I'm going to erase the slope point form. It's telling you to choose slope point form, but I want you to have to think about it a little bit, so I'm just going to scratch that out. End of the day, I got a graph. There's a line here. They want me to build an equation. When I go to build an equation, I have to choose from two forms. I need to choose either slope-intercept form, or I need to choose slope point form. Slope-intercept form is always the preferred form. To create slope-intercept form, you must know your slope and your y-intercept. If you look at this graph, do you know what your y-intercept is 100%? No, it looks like it could be like negative 4.5. Could be a good guess, but it would be a guess. I'm not 100% sure that it's actually at negative 4.5. It could be negative 4.6, but I wouldn't be able to tell the difference, right? So, if you don't have your y-intercept, you need to choose another point on the graph and create slope point form. You can choose any point you want to create slope point form. If you look at this graph, there's 4 points, or 3 points. There's one there, and there's one there. When you're creating slope point form, it does not matter which point you use. You could use any of the 3. And you would still get the right equation. It just might be different from somebody else in the class. Now, if they label one of those points, which we're going to, it's highly recommended you use that labeled point. Because on a test, that's probably the point they use to create the answer. So if there's ever a point given to you, use the point given. We're going to use that point A, so my random point is negative 6, 0. That gives me my x1, y1. What's the other thing I need to be able to create slope point form? The slope. I have a picture here. The best way to calculate the picture slope is to pick 2 points and count your way from one to the other. It doesn't matter which one you do. If I go from A and I go 1, 2, 3, down 3, over 1, 2, 3, 4, that would give me a slope of negative 3 over 4. And you could do that exact same method from any of the points and you would get negative 3 over 4. So if I chose a different point, it would still go down 3, 1, 2, 3, and over 4. 1, 2, 3, 4. It doesn't make a difference. You have slope, you now have a random point, you can create an equation that represents this line. That equation would be y minus 0 equals negative 3 over 4 x plus 6. Notice that it's plus 6, not minus 6, because there's a double negative. I also did something on this question that I would not normally do. Anybody want to guess what I wouldn't normally do? Yeah, I wouldn't write subtract 0. If I take a number and I subtract 0 from it, I have the same numbers. So in my final answer, I would write it as just y. Like that. I wouldn't write the subtract 0. You're not wrong. Like, it's good to know that there's a 0 there, but it's just not necessary. That's creating an equation from a graph. It's the exact same thing we're doing with slope-intercept. It's just you have a slope and a point. No y-intercept. Last example, they want you to look at those equations and write out what the slope is and write out what the point is on that. So, if you look at these equations, what formula is that looking like it's in? What format does that thing look like? The one we're doing right now, slope point form. Right? That looks eerily similar. So if you want to be able to figure out what the slope is on that equation, what would the slope be? Yeah, it's got 1 over 7. So the slope is the number outside the brackets, right? The m. So it's 1 over 7. What's the random point that you know in this graph?
-4.
So this is where people get tricked. Remember that when it's in the formula, it's the opposite symbol. Right? Like, look at this thing. This is x minus x1. So that means that x1 must actually be 4. And in the formula, it's y minus y1. So if you wanted to somehow get y plus 11, it means you must have had a double negative that's actually at negative 11. Worst case scenario, you can always just remember the points are opposite symbols. Right? It's best if you understand why they're opposite symbols, but if you're just looking for a way to get through it, it's always just different. It's always the opposite. Now I want you to try to write the slope for B. The slope and the point for B and C. Leave D for the end. Let's do this. So, if you're looking at B, the slope is always, I'm just going to use M for slope, I'm lazy. The slope is always the number that's outside the brackets being multiplied by the x. So in this case, the slope is negative 5 over 3. The point is the two numbers that are being added or subtracted from the x and the y, and it's opposite symbols. So in this case, my point would be 7, 9. And they're both positive, because in the equation it looks like negative 7 and negative 9, it's opposite symbols. For C, look at that thing, the slope is negative 3. I'll have to put in brackets. The point for this one's a little trickier. The point is at 6, comma, and there's no number next to the y. If there's no number next to the y, what's being subtracted from the chart? 0. Yeah, 0, right? So that thing is 6, 0. The x value is the opposite. There was no y value being subtracted. The reason I wanted to leave D is because D is not a slope point form. If you said that the point was at negative 3, or the slope was at negative 3, that's right. But the point isn't the point we're used to. What form is that? That's Y-intercept. So we wouldn't want to use the opposite number in this case, because this is a different format. The slope in this case is is -3, and the point is actually a y-intercept. That y-intercept is at 0, -6. It's not at 0, +6. Its slope y-intercept is not the reverse. It's actually what it looks like. Because it has a plus b, not a minus b.